Hello and welcome. In this video we are doing something very interesting. As I already did partly in previous videos, I thought it would be nice to design a trading strategy using only numpy and pandas methods. Or to put it in other words, backtest a trading strategy avoiding to loop at all costs. So let's recap the trading rules again. The stock is above its own 200-day moving average. Also, the 10-period stochastic is below 5. When those two conditions are fulfilled, we are placing a 3% buy limit order valid for 10 days. We are exiting on a higher close or after 10 trading days. Please check out the previous video on this strategy if you want more details. Also, please consider that I'm doing some stuff a bit different. First, I was wrongly taking the stochastic RSI instead of the stochastic K there. I fixed it in this video. I'm also treating the buy limit order management way more strict in this video, which is way more realistic. I think the results of this backtest is quite interesting, so I'm already planning on testing this with a vectorized approach on a larger scale. So if you're interested in that, please leave any form of engagement. The preferred one is love. Accepted one is constructive input. The one making me sad is if you skip a single second of this video. Alright, let's get started. First of all, we need some libraries. Finance to pull stock prices from the internet, pandas for data handling, TA to calculate technical indicators, numpy for calculation purposes, and matplotlib to visualize our trading strategy. Next, I'm going to set up a function which is doing the technical indicator calculation for us, which is taking a data frame as an argument. This is adding columns to a data frame, so we are starting with the moving average over 200 days using TA's trend functions and pick the SMA indicator here, provide the close price and set the window to 200. Similar logic for the stochastic K line, we are calling that stock using the momentum functions, pick stock and provide the high, low and close and set the window to 8. In the end, we want to get rid of occurring NaN values here. So let's apply that function, but first we need to pull stock price data. So I'm just pulling price data for Apple starting in the beginning of 2020. Here ending up with a data frame like this containing open, high, low, close data daily. So if I'm applying my indicators function on that and print out the data frame again, you will see that I'm getting two new columns containing the technical indicators. And with that, we have everything we need to check for buying conditions. So I'm going to add a column here, just naming that buy. And this should contain a true value when both buying conditions are fulfilled. First one is closes above its 200-day moving average. Also, the stochastic K line should be below 5. So with that, I'm getting a buy column containing false if those conditions are not fulfilled and true if those conditions are fulfilled. Now let me show you where those conditions are fulfilled. So you see, getting a true value here as the close is above the simple moving average and also the stochastic is below 5. Okay. Now let's define the buy price, and the buy price is pretty much straightforward. So if I have a true value here, I'm simply taking 97% of the close, right? So I can just add a new column here, buy price, and check numpy where my buy column contains a true value. Then I want to take the close and take 97% of that. If my buy is a false value, I just fill in an NaN value. So I'm ending up, let's take a look at the head of this data frame with a buy price column here. And as you see, when I'm getting a true value here, I'm getting a buy price, which is 97% of the close. Okay. And to make things easier, I will fill up this value until this value is changing. So I want to fill up all those NaN values here with this value until here. You can simply do that by just taking buy price equals buy price forward fill. Of course, take the right syntax, and with that, let's take a look at the head again. You see that this value is being filled until it changes. All right, and for the sell price, that's even more straightforward. We're just taking the next day's open, right? So for, let's say, if we would sell here, what we are not doing, but just as an example, if we would sell in this row, we would take the next day's open, so this row here. So how can we do that? Very simple. Define a sell price column and just take the open shifted by -1. So I'm just taking this in this row, just shifting it one row back. Okay, nice. Next, we wanna create columns with a shifted low for buying the asset and a shifted close for selling the asset. And our buy limit order should check the next 10 rows for the low. And if the low is smaller or equal to the buy price, we want to buy, right? So we are creating multiple columns and contain the shifted low price. Okay, so I'm going to loop for I in range 1 to 10, and then I'm creating columns, shifted low, and then plus whatever iteration it is. So for the first row, it is shifted low 1, second shifted low 2, and so on. And then I'm simply shifting the low column by -I. So in the first iteration, -1, second -2, and so on. And same I'm going to do for the close. So what is my idea behind this? I want to have the next 10 days in one single row, right? To check if I'm getting a buying, also a limit buy order triggered, and also if I'm getting my sell triggered. So I want to have it all in one row, okay? So I'm just taking the next 10 low rows and the next 10 close rows here. Okay, so first of all, let's create 2 more lists where we are storing the names of those new columns. This is very helpful when screening for those values. So I'm going to use a list comprehension here and just copy paste. So shifted low for I in range 1 to 11, and same for the close. With that I can just screen for those columns here. Shifted close. Right, so let's take a look at what we are getting here, that it's more clear. So first of all, those 2 lists are pretty much straightforward. I'm just getting a list containing the column names for the low and the close, so I can just index for them later on. So let's take a look at the data frame now. The data frame now contains multiple new columns with shifted low and shifted close. And just to make this clear, I'm taking this as an example. So what is this value? If I'm taking a look at the first rows here, this shifted low 6 is simply, so this value is simply the value starting from this row on. So 1, 2, 3, 4, 5, 6. We got this value. This low value is in my current row now, right? And also the next low value until the 10th row here, right? So I have it all in one row and I can check now. And this is exactly what we are going to do now. So first of all, we are going to just define raw signals. And our raw signals are just those rows where I have a true value in the by column. So these ones, right? Now, what do I have to check? I have to check my low columns, right? So all my shifted low columns, if they are less or equal to the buy price, because then I'm buying, right? So I have to check all those columns now if they're lower or equal to the buy price. So how can I do that? I can just take the raw signals, screen for the lows by just taking the column names. So I'm doing that step by step. If I'm screening that, you see I'm just getting those columns here, right? All the shifted low columns. And I'm using a pandas method now, LE, this is lower or equal to, right? And I'm just checking if they're lower or equal to the buy price. So raw signals buy price. And I want to check that column wise. So with that, I'm ending up with the data frame like this. And let's go over that to understand that. So here I see that in the first row, so in the next row's low, I don't have the condition fulfilled, but I have it fulfilled in the row afterwards. So in the shifted low by 2. Okay. I also have it fulfilled in the row after that, right? Here I'm getting only false values, meaning that this buy limit order isn't going through. Okay. There's also next one is being triggered in the very next row here, right? And so on. Now, what's the challenge now? I have to find the very first true value in this data frame. Why? Because I want to know when the low was hitting the buy limit. And the buy limit, again, is just my buy price, right? And when the first time I'm getting a true value here, this limit is being hit. And with that, the buy limit order is going through, right? So I need the first occurrence of the true values in this data frame. Let's store this data frame in check buys. And now how can we get the first occurrence? By simply using math. So let me explain you what I'm doing. So these are Boolean values, right? So you could typecast them into integer values. And now you see 0 for false and 1 for true here, right? And if I'm taking the row-wise cumulative sum now, I know that the first occurrence must be the cumulative sum of 1, right? So let's take it the first row as an example. Cumulative sum row-wise, 0 plus 1. So here, the cumulative sum is 1. Here, the cumulative sum is 2. 2, 2, 2, and so on. Right? So when the cumulative sum row-wise is 1, I know that this is my first occurrence of the true value. So let's do that. Let's call that check buys sum and use check buys cumulative sum row-wise, which is equaling 1, equals 1. Right? So with that, we are getting the cumulative sum here, which is equal to 1. So in that case, this is the first occurrence, right? Here's the first occurrence. Here's the first occurrence, and so on. So how can we cope situations like this? We have a true value here, but also a true value here. Well, we can just index our check buys data frame with this data frame and thereby get rid of those true values which are subsequent, right? So when I have a true value here and a true value here. So what do I mean? If I'm indexing the check buys data frame for this. So let's take a look at the check buys once again. And let's take this example. So I have this. I have the 10th May here, right? 2021. True, true. In the sum, th May, I have true and false. So if I'm indexing now, I'm getting this value, right? So if I'm taking check buys and index for this, I will get a 1 here and an NaN value here, right? So go over it once again, Boolean indexing, very important. But with this approach, I'm getting the first occurrence of the true values in this data frame. As you see, I never have the case that I have a 1 more than one time in a single row, right? So I'm just calling that filter buys. Now, what do we want to do with this filter buys? First, I want to transpose this data frame. I want to have the index as the columns and the columns as the index. I can just use T to transpose a data frame. So with that, you see, I have the dates as columns and the shifted lows as rows here. And if I'm taking the index maximum now, I'm getting the 1, the first 1 in this row here, which is right. Because on this date, the shifted low 1 was triggering the buy limit threshold, right? So I want to have this one here. If I'm taking index max now, you will see that, and now let's go over it once again together. If I'm taking check buys now, for the very first date, it was shifted low 2, right? This was the first occurrence of true. And if we are taking a look at that, we have it here. Second day, we didn't have a single hit, right? So this buy limit order didn't go through. So we have an NaN value here. So those NaN values are the not going through buy limit orders. Next one, this date, 22nd. First occurrence, shifted low 1, shifted low 1, and so on. Let's take this one because it's shifted low 8, it's another situation. 6th, we have false, 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 true value at shifted low 8. Okay, so yeah, I think you got the point here with that. So this is how we are getting our, let's call them raw traits. Now, why are they so important? We need to keep track of those NaN values here. So those buy limits order which weren't going through, because they are still part of our trades, right? So imagine you are in a trade, right? On a specific day. You're firing a buy limit order and it's being executed after some days. You're already getting the signal for the next buy limit order, which wouldn't go through. But if you are considering this buy limit order here and not screen if it's really in place compared to the previous trade, you would unnecessarily wait X days here until this buy limit order is going through, right? Because whenever you are placing a buy limit order, you have to wait at least 10 days, right? Because this is the amount of time you are waiting until your buy limit order is triggering. So this is very important to keep this information here. All right, but it will become more clear in the course of this video. Just take it for now. We have to save those dates even though those trades weren't going through. Now, what am I going to do now? The next logical step would be to take the signal dates and add this number here. So the amount of shift, so the amount of days when this order is being triggered, to store the buying dates. So in this case, 28, we would take +2. So we would end up at roughly the 30th if we don't have a weekend or something like that. So the next thing we are going to do is extract those numbers. Okay? So I'm going to call that extract buys raw. And what I'm going to do is I'm splitting those strings here by the underscore and just filter for the last element. And with that, I'm getting the number. Okay? So how can I do that? I'm taking raw trades, string split, take the underscore and index for the last element. So with that, I'm getting the numbers here. All right. So what I want to do now, so I'm keeping this because this is important later on. I'm going to explain why I'm keeping this like so in some seconds. But let's move on with the next step first. So this is very important, again, just to emphasize that, to keep those trades which weren't going through. Now I'm going to create a variable, extract buys, where I'm going to fill those NAN values. And I'm filling those NAN values with tens. Why tens? Because when I have a buy limit order, which isn't going through, anyhow I have to wait 10 days, right? So if I have a buy limit order, I have to wait 10 days until I can take the next action. So I'm going to store tens at the NAN values here. Just using extract buys raw, fill NA, and pass 10. So with that, I have my signal dates and the dates, the number of days from the signal day on when I'm buying. So the only thing is to add those days to these dates now. Okay, and I'm taking an approach for that, which I quickly want to explain to you. So to add this number of days, I could just take my raw data frame. And let me just show you with this example. It's the most straightforward way. If I'm screening for that date, and this colon is meaning from that date on, I can just pass this as an index to this index to get the 2 days after this date, right? So if I'm taking a look at this index and index this index for the second, or for the second element here, so element number 2, not second element, technically a third element, but element number 2, I'm getting this date, which is correct, right? Because this date plus 2 days is this date. So I'm going to index with this number here. And with that, I'm getting the date for this date. And what I'm doing now is I'm simply looping over that. I'm taking the date, index for this number, taking the date, index for that number, and so on. So I'm doing that in a list comprehension and store that as by dates. So I'm taking df log. This is our I. Index for, so as this is object formatted, we have to do an integer typecast here of E. So the E are the values of this series, and the I is the index of this series. So we are just looping for IE in zip extract buys index and extract buys values. Of course, care about the right brackets or parentheses here, and with this we're getting our buy dates. So makes sense, right? 30th here, so I was going through that. All right, so just this date plus those days here. And with that, we have our buy dates, right? And we can use those buy dates to create a buy data frame by simply using our raw data frame and index for those buy dates. So with that, we have our buy data frame. All right. Now, before moving on to the selling logic, I want to quickly show you why keeping those NaN values is so important. So I'm going to open up a data frame for that. Bad naming, I know. Don't know of a better name right now. I'm opening up a data frame on our extract buys raw variable. Just as a recap, so what was this variable? This variable was containing the not going through trades as NaN values. So I'm going to pass extract buys raw and set the column names to NaN check. Okay, so I have this data frame now, and know, okay, these are by limit orders which aren't going through. And I can add to this data frame, I can add my buy dates now. Just assigning my buy dates list, which I just created here. And with that, I'm getting this data frame. And this data frame is a good overview of what we did until now. So let's recap. We have the signal dates here, 28 here. And this by limit order was going through. So the asset was bought on the 30th here. This by limit order didn't go through. This also. Unfortunately, we don't have a case now where I can explain it to you. But imagine you have a trade which is being in, or which is overlapping with this trade. So this is an NaN trade, and this is an overlapping trade. So I simply have another buy signal within somewhere in this time frame. Now, if I would just filter out the NaN values here, I would miss something out here, right? Because it could be that this, if it's overlapping, isn't even triggering this by limit order. So I don't have to wait these 10 days long, right? Because this order couldn't have been executed or couldn't have been triggered here because it is overlapping with the previous order, right? So it is important to store those not executed orders here in this data frame. All right, but yeah, so let's move on to the selling conditions. And the selling conditions, if you understood the buying logic, is basically nearly exactly the same. So we are going to define a check sells variable, use our buy data frame, and now we are screening for the close columns. So I'm just taking call names close, checking for greater than the buy price, because the exit condition was the buy price is greater. The close is greater than the buy price. So we are checking if the close values here, so the shifted close values are greater than the buy price, and do that column wise. And with this, we are getting a data frame like this again, right? You already know that. So we have true, true. So you see for the most cases, the next day's closes already. The triggering exiting the trade, right? So here in this case it doesn't, it does after 2 days, but in the most cases here, yeah, here 3 days and so on, right? Now I'm doing one change to this data frame, because as you remember, we have to exit the trade after 10 days if we are not getting a hit here, right? So if the close is not above the buy price. So to make things very easy, I'm just setting the shifted close 10 to true for all values here. And with that, I am, if I'm not getting a close hit here, I'm just exiting the trade as at shifted close 10. So I'm just setting all values in this column to true. And as said, with that, I managing that I'm exiting the position after 10 trading days. So as said, I'm just taking the close column names, index for the last element. This is simply shifted close 10, right? I'm just too lazy to write stuff here. So shifted close 10. And I'm setting that to true. And with that, I have the last column of this check cells as true. Okay. All right, perfect. Now, same thing as before. We are taking the cumulative sum row-wise and check where it is 1. Same logic as before. So check cell sum is check cells, cumulative sum row-wise equals 1. And with that, we are getting the known data frame again, and we are filtering that using check cells with this as the Boolean index, check cells, and with that we are getting the first occurrence of the signal, right? So in most cases, after 1 day, here after 2 days, here even after 3 days, and so on, right? Perfect. Now, same procedure as before. Defining raw cells, shifting the index with the columns of this. So let's do it step by step. Filter cells, transposing this data frame, and then find the index max. So IDX max, and get the first occurrence, and yeah, as you see, we're getting the same series as with the buy values here. Okay, so we can just store that as raw cells. And now, again, the same logic. We're using extract cells and split the string by the underscore. So I'm just doing what I did before. So I'm splitting this and extract this last number to add this number to this date to have my selling date. Okay. So split the string by the underscore, take the last element. In this case, we can directly typecast that into an integer because we don't have any n values. So using extract cells, as you see here, now we're getting the days. And again, the exact same as before. So we are defining cell dates using the same logic, list comprehension dflog for I, from I on, then index for the E, and again loop over this series and pass this as the I, this as the E, for I, E and zip, extract cells index, extract cells values, cell dates. Here we are. Now remember our data frame where we were storing the NaN check and the buy dates. We are just appending the sell dates now to this. So calling that sell dates, and provide our sell dates, and we're ending up with a data frame like this. Now we have to do one amendment to the rows containing NaN values. So again, these are by limit orders which didn't go through, right? And as the buy date or the buy dates column is relevant for us because this is just the date from when we can set up new trades, right? Because we waited 10 days here. From this signal day on, we waited 10 days, so this is the buy date. And then we can get into the next trade. So what I want to do is, as this is a wrong value or a non-making sense value for a not going through by limit order, I just want to set the sell dates value to the buy dates value. Okay? So only for those rows containing NaN values, I'm setting the buy date value on the sell date column. How can I do that? I'm using df_log and now screen for the NaN check column is an A. Then I'm screening for the sell dates and set them to exactly this one here. And screen for the buy dates. So again, what is this line of code doing? It is screening for the NaN rows and then is setting the sell date to the buy date value. So in this case, the sell date will be the 8th of December instead of 9th, 21st instead of 22nd, and so on. You will see when I execute this line. So let's take a look at that again. You see for the NaN values, we have the exact same values here now, right? And other rows stay the same. And that does make sense because we are using this data frame now to extract our real trades. And what is a real trade? A real trade is a trade where the index is larger than the previous sell date. So this value must be larger than this value. Otherwise, you have overlapping trades. So what I'm going to do is I'm shifting the sell dates column by 1 and just check if this value is larger than the index value. Okay, so first I'm creating a placeholder variable. Why am I doing this? Because when I shift sell dates by one row, the first row is being excluded, but the first row is always taking place, right? Because it's the first trade here. So we will take care of that in some seconds. So as I said, we are checking where the index is larger than the shifted sell date. Okay. Ending up with a data frame like this. And now I'm just adding the first row from our df_data frame. So I'm storing that in real trades now. Use only the first row and append trades. Right, so now I have the first row included here. Okay, and now let's compare what did change, right? I think that's the easiest way to understand what I did here. So let's take a look at our raw trades here. And let's check. So what's missing? So this one is missing. Why is this one missing? Let's understand why this is missing in our final frame. This trade had a signal at the 19th January. But the 19th January, when I was at this date, I was still in this trade because it was sold at the 20th January. So this buy limit order wouldn't be triggered when doing this as a live trade. Okay? So this is how the logic is working. As you see, I'm keeping all my NAN values here, right? Of course, we will drop them, but we will drop them now because we needed it for all the previous checks, as this can make a big difference here, right? Because you always, when you're triggering those orders, and you have to check if they're triggered, you're always waiting 10 days. And with that, you are excluding the potential trades over the next 10 days, right? This is very important to drop the NAN values at this point in time and not anywhere before. So we're using real trades executed by just dropping the NA values here. All right. And with that, finally, last but not least, we have our executed trades for Apple, right? And now, of course, we want to do some visualization and actually check what profits did we make. But this is easy now, right? So we can just create the buys and then use our raw data frame and just log for the real trades executed and then the buy dates and then the buy price, as this buy price is in this exact row. And the same for the sales price, right? So this is very easy now. And the sell price is the next day's open, and we also already have that stored. So taking sell price here, and with that we have our buys and our sells. Pretty nice, right? And with that we can do our profit calculation. So let's do that here. Our profit is sales values minus buys values, and we are setting that, of course, take a equal sign here and set that into relation to the buy values. With that we have the relative profit per trade, and as you see, only positive profits here. So quite nicely, let's calculate the cumulative profit. %, not bad since 2020, right? But yeah, if you take a look at Tesla's profit, Tesla most probably outperformed this strategy. Or not Tesla, sorry, Apple. I tested, right? Okay, next, visualizing stuff. So we are plotting the close, just to have the price chart. Then we're also plotting the moving average. Don't necessarily have to do that. And then we are plotting buys index. So where's buys? These are just my buying dates and the buying price, right? So index is my X and price is my Y axis. So buys index and buys values. Set a marker to a wonderful green arrow, and same for sales. So I've covered that in many previous videos, but just for the sake of completeness here. So these are our visualized signals here. So just in case you're wondering, hey, why is this buy signal so off here, or these buy signals so off the chart? That is because we were buying for the low, right? So if you plot the low instead of the close here, you will see that they are on the line here. Makes sense, right? And yeah, let's play a bit around and let's take a look at the other asset. So I made a mistake and said Apple here or Tesla. So let's actually do that for Tesla. Yeah, we checked Apple, so let's check Tesla. Run or below. Let's see what we got. Well, 57% profit, not bad here, right? But yeah, that's it. So using only pandas method, only vectorized method to backtest a trading strategy. I know, quite a long video, but I hope this was helpful. And yeah, next video, of course, doing that on a large scale. So backtesting more than 500 assets and see what this strategy can do. For that, of course, there has to be some refactoring, right? So the buying and selling logic can be put together, surely. But I think for didactic reasons, it was good to go through all the steps. So yeah, thank you very much for watching, and I'm looking forward to see you in the upcoming videos. Bye bye.